Lesson 84, identifying quadratic functions. Basically, if you have an x squared in your function and the coefficient of x squared is not equal to 0, then it's a quadratic. So in standard form, a quadratic function looks like this. F of x equals a x squared plus bx plus c, where a does not equal 0. So as long as you have an x squared term, it is a quadratic. So this is your quadratic term. This is your linear term. And this, the c, is called the constant term. So I'm going to give you some examples of polynomials, what the degree is, so we're going to look at their degree, and we're going to name them using the degree. So here's an example of a polynomial, 3x plus 2. The degree is the exponent on the largest term. I mean, let's see, how do you say this? On the variable, when you look at the variable, you look at the exponent, the largest exponent on that variable, and that's the degree. So here's the variable x. It has a 1. There's not any other x's, so the degree is 1. This is going to be a linear function. A quadratic, x squared plus 4x minus 5. The degree is 2 because we have an exponent of 2 and an exponent of 1, and 2 is bigger. So this is a quadratic. Quadratic. That means I spelled this wrong up here. It's not quadratic, it's quadratic. There we go. Okay, then we have, here's another polynomial, 2x cubed minus x squared plus 1. The degree is 3, so that's the largest exponent on x, and this is called a cubic function. So when we graph a quadratic, so a quadratic graph is a parabola. Everyone say parabola. Okay, good. So here is a picture of a parabola. It kind of goes like that. Continues on each end, kind of scoops down and goes back up. Now you might have a parabola that goes upside down. It's just this shape facing up or down. So if you have, here's an example, f of x equals 5x squared minus 3. We can look at it and say, okay, the degree is 2, so this is a quadratic. When you want to graph quadratics, you want to pick at least 5 points. You've got to get points on either side so you can see where does it turn and where does it go up or goes down. So we're going to pick 5 points. I like to do both positives and negatives. So I'm going to say -2, -1, 0, 1, 2. I'm just going to pick those points. -2 squared is 4, times 5 is 20, minus 3 is 17. -1 squared is 1, times 5 is 5, minus 3 is 5 minus 3 is 2. 0 squared is 0, times 5 is 0, minus 3 is -3. 1 squared is 1, times 5 is 5, minus 3 is 2. Notice that it's starting to come back up again. 2 squared is 4, times 5 is 20, minus 3 is 17. So when we graph this, we have, let's see, 0, -3 looks like our lowest point. At 1 and -1, we've got to go up to 2. I wonder if I should count by 2s. I'm going to count by 2s, okay? So we're going to go up to 2. Oh no, if I count by 2s, I've got to change this. So we're counting by 2s. And we want -3 right there. We go. So then at, wait, if we're counting by 2s, that means that 1 is right here. So -1, 2, 1, 2. Okay, 4, 6, 8, 10, 12, 14, 16, 18. So it would be in between 16 and 18. So at 2, we're going to be up at 17, and at -2, we're up at 17. So you can see how if we were to kind of connect these dots, make it into a parabola, kind of looks like that. Not the perfect, but it'll do. So when, in our standard, wait, let's go back up to our standard form. We had a times x squared. So if you look at that a, if a is greater than 0, so if a is positive, then it will open upward. If a is a negative number, so it's less than 0, it's going to open downward. And that's the end of our lesson.